Good morning, guys. Today we are back with another problem, and today's problem is merging the two binary search trees. Okay, so I can write the question as merge two binary search trees. So what is this? This is basically an easy problem. This is a basically an easy problem, and what basically we are going to do over here is, if you see carefully, we have a binary search tree 1, we have a BST 1, and we have a BST 2. So in the binary search tree, what we can see is 5 and their children are 3 and 6, and their leaves are 2 and 4. Similarly, if you see, 2 has one leaf 1 and children 3, 7, and a leaf 6. So what we have to do is we have to merge binary search tree 1 with binary search tree 2 and return the result in a sorted manner. In a sorted manner. Okay, so this can be done using the technique of in order traversal. This can be done using the technique of in order traversal. So I've already discussed multiple times that what is in order traversal. In order traversal is nothing but left, root, right. Okay. So what is this? So basically, say for example, you will be having a particular binary tree like this. Okay, binary tree like this. Okay, and in this particular tree, suppose I'm going to print the binary tree, or I'm going to traverse through this. I'm not going to start from the root and then go here and then go here. Then it's a binary tree. But in case of a binary search tree, what we are going to follow is an in-order traversal technique, where I will start from the left, go to the top, okay, and go from the top to the right. Okay, so this is known as in-order traversal. Okay, so in this in-order traversal, what we can do, we are recursively calling the function itself to traverse through the binary search tree. So first we are going to have, if we try to formulate the solution, we have to we will be given a function with list data type, and we will be having a node root in the parameters. And now what we have to do is we have to call the function, okay, and then we have to traverse through it. So if we check the example, we will be seeing that we will be giving a default function known as list merge, and we will be having a node root 1 and node root 2. So if I want to know what is this, this is known as BST1, okay, and this is nothing but BST2. This is nothing but BST2. So when we will have a linked list, we will have a sorted array list. Okay, we will have a sorted array list known as sorted list. So what we are going to do is we are going to do the recursively call in order traversal for BST1 and BST2, and we have to lastly we have to sort it. So we'll use the list dot sort, then integer dot compare to, which will help to sort the sorted list in sorted ascending order of the natural order of integers. Natural order of integers. So that means the integer values will be sorted in natural orders. So this is our main function in order traversal, where we'll have a root and a sorted list. If the root is equals to null, we'll return, or else we're going to go to the left side or to the right side, and then this you can see we will have a rooted data. So the sequence we are following is left, root, then again right. Okay, this is how you can merge two binary search trees and make one binary search tree and into sorted order. Okay, so this is a maybe a easy level, but I think they've given it under a medium level problem. So let us do this. Okay, so what I can see is what I can see is ah so we have a public list integer merge value, right? We have public list integer merge value. So what we can see is we can call the function, we can call the function. Okay, so we can call the function in order traversal. Okay, so void in order traversal. In the in order traversal, what I'm going to do is I'm going to take the node class, node root. Okay, so we'll be having a node root, and we will be having a sorted list, maybe. Yeah, we'll be having a sorted list. So list of type integer sorted. Okay, what we are going to do here, we are going to first check if root equals to null, then return. Then we are going to traversal of root dot left and sorted dot add root dot data root dot write sorted. Okay. After this, we can create a new array list. Integer, say result equals to new array list. Now we can call this function in order traversal of root 1 and result in order traversal of root 2, then result dot sort integer uh, I guess that's the command, compared to, yeah, integer compared to, we can return result. Yeah, let's try to compile. So in order traversal cannot find symbol node and result, root 1, is it so? Root 1 and result, root 1 in order, yes, in order traversal. What is the problem? In order traversal spelling be correct. Root 1 method in order traversal, a node root strange new news. Okay. I guess I have to let me just check. So if I quickly check, what is there? So we have a list merge, okay, node root and root 1 and root 2, okay. We have a list of integer type result equals to new array list, okay. We are calling the in order, okay. So I already told you there is a spelling mistake. So again, then there is a mistake. So yeah, so we have successfully completed this particular problem, and I hope you could understand binary search trees in depth, and this will help you improve your concepts as well. Don't forget to like, share, and subscribe to this channel, and it means a lot. Thank you.